going to talk a little bit more about the fundamental theorem of calculus, part 2 today. Also, thank you to Leibniz and Newton, the most important theorem of elementary calculus. And yes, this is the beginning of calculus, so it's considered elementary calculus. I know that most of you don't feel like it's elementary, but it is. We discovered the other day that the area under a curve, or an integral for that matter, was the antiderivative. So if f is continuous on a to b, then the integral from a to b is equal to the antiderivative with b plugged in minus the antiderivative with a plugged in. It works because they take the area from 0 to b and subtract the area from 0 to a and are left with the area from a to b. I'm going to show you a few quick examples. This will be around forever, the rest of the year and beyond. So make sure you're catching on to this method. So evaluate the definite integral. First thing you need to do when you're evaluating a definite integral is antiderive. So antiderivative of x cubed is 1/4 x to the 4th. And this new notation means we have yet to plug in our endpoints. Always plug in your upper limit of integration first. So this is going to equal 1/4 times 1 to the 4th minus 1/4 times negative 2 to the 4th. So we get 1/4 minus negative 2 to the 4th is 16 times negative 1/4 is 4. So we get negative 3 3/4 as our value. No tricky steps there. We will use integrals for so many things down the road, but it's comforting to know that it doesn't have to be hard. This one, let's antiderive. Not plus, minus 1/3 y cubed, and all of this is from 0 to 4. We 4 plus 3 halves times 4 squared minus 1/3 times 4 cubed. If we plug 0 into all of that, we just get 0. So I'm going to go up here. 4 plus 4 squared is 16. Divided by 2 is 8. 3 times 8 is 24. And minus 1/3 times 4 cubed. 4 cubed is 64. Times 1/3 is 64 thirds. So we're really trying to add 28 minus 64 thirds. $28 is really 84 thirds minus 64 thirds, which gives us 20 thirds as our answer. Common denominator from the 28 to the 84 thirds. If that is something you're not able to do, make sure you see me so we can talk about this. Example 3. The integral from pi to 2 pi of cosine of theta d theta. Antiderive. We get sine of theta from pi to 2 pi, which is equal to sine of 2 pi minus sine of pi. Sine of 2 pi is 0. Sine of pi is 0, so that integral value is 0. Number 4, find the area under the curve of the parabola y equals x squared over the domain 0 to 1. So we're finding 0 to 1 of x squared dx. Antiderive. We need to go from 0 to 1, so we get 1/3 times 1 cubed minus 1/3 times 0 cubed to get a value of 1/3. On your calculator, we'll talk about this more tomorrow. These are kind of old instructions. If you have an 83, you hit math 9. FNINT will show up. You put the function, comma, x. Tell them what your variable is, that you're using an x, comma, your lower limit, comma, your upper limit. Works the same way on the graphing screen. If you have a TI-84, you can hit second window and select, don't remember what number it is, but select your one that says FNINT, and it will look just like an integral. It'll have these boxes with a space here, and I think it has a set of parentheses in the middle when it pops up, and you just plug things in where they go. We'll talk about that more tomorrow. Make sure you have figured out how to evaluate them on your calculator. Most of them would be on a non-calculator portion, so don't ever begin to rely on that calculator. I'll let you know when it's safe to rely on the calculator.